Hello there, Algebra 2 students. Mr. Weber here. Today we're going to talk about graphing sine and cosine functions with period shifts. Now, this is slightly more complicated than what we did last time with vertical shifts. So if you need to watch this video again, that's perfectly okay. If things don't click the first time, that's normal. Remember, this comes from pages 381 to 390 in your textbook. Please don't be afraid to watch this recording more than one time or to reach out to other resources. Okay, so we've talked about these trig functions, and we've changed our amplitude up front by adding that a value. So remember, a is going to change the amplitude. We've talked about moving these graphs up or down. Remember, that's the k value, so k at the back is going to do that. Today we're going to have a b value that's going to be inside of the trig function that's multiplied by our variable x. So the b value is what is going to change the period of the function. Remember what period is. That's the distance, the horizontal distance, from one point on one cycle to the same point on the next cycle. Okay, in science you may have talked about this as like wavelength. But we refer to it as the period. Okay, so the period is equal to 2 pi divided by b. Okay, that is the length of one cycle in this periodic function. Okay, so if you see b, if you take p and divide it by 2 pi, that's the length of one period. Okay, another way to think about it is that b will tell you how many cycles will occur from 0 to 2 pi. All right, so 0 to 2 pi is kind of like one full rotation around the unit circle. And if this was like, if b was like 5x, then I would expect there to be 5 complete cycles, I'm sorry, 5 complete cycles every time we spun around. All right, let's see if that makes sense. Let's try it again. Here we go. Graphing cosine. By now, hopefully this is pretty straightforward. We just got to remember cosine starts with what? Starts with 1. So we graph those points: 1, 0, -1, 0, +1. And notice how we've always done this. We've spaced these out so that each step is a pi over 2 horizontal distance. So we go from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi. And then from this, the distance from 0 to 2 pi, we see one full cycle or one full wave. So we start at the top, we fall all the way down to the bottom, we come all the way back up, and it's one full cycle. Okay, we see our back end, and now we can go ahead and graph this. So get my pen. Let's graph this. There's our wave. Okay, now the period is 2 pi divided by b. Well, what is b in this case? B is the invisible 1. So the period is actually 2 pi divided by 1, which is just 2 pi. All right, and that makes sense because there's the distance from here all the way to here. There's our period. From 0 to 2 pi. Now, how many cycles do we see from 0 to 2 pi? Well, we only see one distinct wave. So far, so good. That should, by now, hopefully be pretty straightforward. Now, look what happens when we add this 2 here. Let's see how we're going to graph this. We're going to start the same way. We're going to still think about the 5 points we always have. Cosine's our x value. It starts with 1. So we're still going to think 1, 0, -1, 0, 1. Here's the part that's different. Our period is 2 pi divided by b. Well, what is b in this case? In this case, b is 2. So our period is 2 pi divided by 2. Well, what happens? The 2's are going to cancel, and our period is just 1 pi. All right, so here's the way this works. Here's the way we graph this. This is going to be slightly different. What we're going to do is we typically see a full wave between 0 and 2 pi. So whatever this period is, what we need to see is all 5 of these points have to occur within 1 pi unit. So start with your first point and start with your last point. Graph those two things. Okay, now we're going to graph those over a span that is 1 pi distance. So look what happens. All right, so typically my first point and my last point are separated by 2 pi. So again, looking at number 1, we're looking at this point and this point. You can see how spread apart they were. I'm graphing 1 and 1, my first and last points, over the span, which is pi, that I get from the period. Okay, so basically what I do is I find out what the whole period is. I put my first and last point in, and then I just try to cram everything else inside. Okay, now it's not willy-nilly, so you gotta do it the right way. So this -1 is directly in between +1, the two positive ones. So if I look at this span here, what's numbers exactly in between would be right here at pi over 2. So this is going to be right here at pi over 2. This is the middle point. That's going to be -1. So I graph a point at -1. The last thing I do is graph these two other points that are exactly halfway between there. And I don't have a line on my x, so I'm going to have to just estimate. So here's what I have. Notice how I have the same thing I had before. It goes from 1 all the way down to -1, all the way back up to +1. But the difference is it looks like it's been compressed horizontally. And that's because it's all happening in a shorter span. It's not happening in a period of 2 pi. It's happening over a period of 1 pi. Does that make sense? I hope so. All right, so here's what we got to do. We just got to duplicate this again. All right, so if I just follow that same pattern, every step is like 1/4 pi over 4. And once you have that pattern, you can work backwards to do the exact same thing in the opposite direction. There's one cycle. There's a second cycle. And now we graph it. Okay, now what's our period? Well, we already did that. The period was pi. Now here's the next question. How many cycles do we see between 0 and 2 pi? All right, so let's see here. Let's use a blue one. All right, so let's see here from 0 to 2 pi. So here's 0, here's 2 pi. So we're thinking, how many cycles are we going to see here? Well, let's follow the wave. We have 1 full cycle, two full cycles. So there's 2 full cycles between 0 and 2 pi. Does that make sense? When I say full cycle, I mean that starting at its initial point, it's falling or rising, going all the way through that period, coming back to the exact same point. All right, let's try a couple more. Some of these you just have to see and get a sense of how it works by repetition. So if it doesn't click the first time, reach out to your teachers, watch the video again, look for the resources, and practice, practice, practice. All right, so here's sine. So we'll think about sine. What do we think about when we see sine of x? What's the 5 numbers we got to remember? Animations got messed up there. All right, so we think 0, 1, negative 0, 1, 0, negative 1, 0. So we graph that normally. We step backwards and graph that. And then you can graph your function. All right, what's our period? Okay, so again, what's the b value? B value is the invisible 1. 2 pi divided by 1, which is 2 pi. And there is only one cycle here between 0 and 2 pi. Okay, look what happens with number 4. Now our period is going to change. So it's sine So we're still thinking 0, 1, 0, -1, 0. But now we do have a period change. Now our period is, the b value is 2. So that 2 corresponds to this 2 here. The period is equal to 2 pi divided by 2, which means the period is going to be 1 pi. So we need all 5 of these points, all 5 of these steps to take place between 0 and 1 pi. Okay, so what I do is I think about my first step, which is at 0, and my last step, which is at 0. And I graph those first. The first one I put at 0, the second one I put at pi because that is the length of my period. Okay, then I find the middle distance in between those 2 points. There's my middle point. What's the middle value? It's still going to be 0. So I graph that point. Then I cut those 2 points in half. Here and here. Now where are those points going to be? Those are going to be +1 and -1. +1 and -1. And there's your full cycle. All right, so now we're just going to repeat this pattern till we get to 2 pi. Do the same thing in the opposite direction. And then you can graph. Now these questions here at the bottom are designed to help you understand this, because remember, it's possible we just give you a graph and then we say, you know, what's the period of this function, or how many cycles do you see between 0 and 2 pi? Okay, so let's tackle this in that sense. If you look at the graph, and let's assume that you're given this graph and you're asked about the period. All right, so take your starting point. All right, you can see here that because it's sine, it's in the middle of the wave and is going up. The wave is going up, it's increasing. Let's find the next point where it's the middle of the wave and it's going up. So I'll slide across. Is it this point? Well, that's the middle of the wave, but this one's going down. So that's not our point. So keep on going. Here's the next point in the middle. It's in the middle and it's going up. So this is going to represent our period from this distance here at 0 to this distance right here. Well, where is that? That's at pi. So there's your period. Forgot some of my animations. The period's pi. Okay, now, how many cycles do we see between 0 and 2 pi? Well, there's one cycle. And look what happens. We get a whole nother wave here. So there's 2 distinct cycles here. Done and done. Okay? All right, halfway done. If you want to take a pause and try it on your own, that's fine. Although this is one of those topics where you might want to stick around and watch it one way all the way to the end first, and then maybe try those answers on your own. So here we go. Making things a little more complicated here with number 5. And we got an amplitude shift. All right, but it is sine. So we're going to think about our same numbers, same 5 numbers. 0, 1, 0, -1, 0. Okay, we're thinking about that because it is sine. So now we got to think about the amplitude. The amplitude is 3. All right, so we're going to multiply everything times 3. Okay, so far so good. Now we're going to think about what the period is. All right, our b value here is 2. So it's 2 pi divided by 2. The 2's cancel out, and it's pi. Is it always going to be divided by 2? No, we're just trying to make it easy on you. All right, so the period's 2. The period's pi. So we're thinking about the first number, which is 0, and the last number, which is also 0. Those 5 steps have to take place over a span of 1 pi. First one's at 0, this last one's at pi. Then we're going to think about our middle value, which is also 0, so we find the point right in the middle, also 0. Then we have positive 3 and negative 3. Positive 3, negative 3. Right there in the middle. And once we see this pattern, we just repeat this for the next wave. So we get 2 full waves. Same thing going backwards. And now we graph. You can see when this period is bigger than 1, when the b value is bigger than 1, what happens is it appears that the graph gets kind of compressed horizontally. Everything gets kind of closer together. All right, what's the period? All right, let's look at the graph this time and see if we can find the period just by the graph. You already know what it is because we calculated it. Sometimes it's really hard to change my pen. All right, here we go. So we're starting at 0. We're going to take this wave going all the way up, going all the way down, back to this point. There's the next point. Where is that? That's at 1 pi. There's one cycle over the course of 1 pi. Let's keep going. How many waves do we see? Up and down and back. There's a second wave, a second cycle. So there are 2 distinct cycles between 0 and 2 pi. Okay, look at number 6. Number 6 is a little crazy. First off, think about your trig function. Well, it's cosine. So it's going to start at 1. There's your 5 numbers. Now what's the period? Well, the period's 2 pi divided by b, but b in this case is 1/2. So what we have is 2 pi divided by 1/2. All right, how are you going to deal with that? Think about your rules. Keep, change, flip. Convert that division into multiplication and take the fraction on the bottom and flip it upside down. So it becomes 2 times 2 over 1, 2 pi times 2 over 1, which is going to equal 4 pi. So now these 5 steps should take place over 4 pi, but we have a problem. Look at our graph. The largest number we see is only 2 pi. Okay, so these 5 steps should take place over the course of 4 pi, but we only have a graph for 2 pi, so we have a couple options. Could you just extend your graph and maybe draw it off the side and make it bigger? That's always one option, but sometimes you don't have the actually real estate on your paper to be able to do that. So it's a good thought, but won't always work. All right, so let's think about this another way. If the distance of the period, the distance of one wave, is 4 pi, and we only have 2 pi, well then how much of this wave should we see? All right, if it takes 4 pi for us to see the whole thing, and we only have half that space to work with, 2 pi is half of 4 pi, then we should only see half the wave. Does that make sense? So let's cut this in half. All right, what that means is that the middle point is now our end point. So what we're going to graph is just this step right here. All right, so that means the bottom part is going to start at 1, but the last number should be at -1. Okay, so if it takes 4 pi to get here, that means this is what we should see over 2 pi. Let's follow that backwards, and you get something that looks like this. That's crazy. What happened? All right, if you think about it, it makes perfect sense. This b value was less than 1. It's a fraction. Remember when our b value was more than 1? It caused this graph to get kind of scrunched up like it did on number 5. All right, remember this 2 was bigger than 1, and this looks like it got compressed horizontally. Does that make sense? Almost like you had like a spring and you're pushing those two sides together and everything's getting smaller. Well, if the b value is less than 1, like in number 6, it's like you're taking that spring and you're stretching it out. You're pulling it out this way. You're making everything longer. So we only see half of the circle or half of the cycle. Okay, so what's our period? Our period was 4 pi. We calculated that right here. Now let's look, how many cycles do we see from 0 to 2 pi? Well, here's 0, here's 2 pi. Do we see a full cycle? Nope, we only see a half a cycle. Remember, this b value is what this number should be. Always, 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 always. Okay, if it's 2, then this is going to be 2. If it's 1/2, then the number of cycles you'll see is 1/2. That b value will always tell you the number of cycles that you should see between 0 and 2 pi. Let's try 2 more. I got my animations messed up. All right, so we have cosine here. So we're going to think starting with 1. First thing we're going to do is we're going to multiply by -1. So 7 is a great example of how we're throwing everything at you at 7. If you can do 7, you can do all of them. It also means that if you get 7 wrong, don't feel bad, because this is the one that has everything going on with it. All right, so we started with cosine, and then we're going to deal with this negative out front. So we multiply everything by -1. So all of our signs change. Negatives become positive. 0 stays 0. The next thing we're going to do is we're going to deal with our k value, this one out back. So then we're going to add 1 to each value. -1 becomes 0, 0 becomes 1, 1 becomes 2, so on and so forth. Everything gets added by 1. Okay, now we go to graph. Before we can graph it, we got to figure out what the period is. All right, so our b value here is 2. So the period is going to be 2 pi divided by 2, which means the period is pi. Okay, the period is pi. So it means that what we should do is we should start with our first and our last. This should take place over the span of 1 pi. So starting at 0, ending at pi. Okay, then find the number directly in the middle. That's 2. That should be directly in the middle. There we go, 2. Now we'll take those 2 points and cut them in half, and they should be at 1. Take those 2 points, cut them in half, something like here and here, and look what happens, 1 and 1. All right. Once we have that first template, we just take that and repeat the cycle for the next steps. All right, then we work our way backwards, repeating the same cycle. All right, so this should look uniform. So if we look at your own graph, if you have one section of it that's really close together, but another section of your graph looks far apart, then you made a mistake somewhere. So when we take those same steps, make sure that you're taking the same horizontal distance as you did in that first one that you built. All right, you're basically using that first one as a template for the rest of the graph. All right, that's the benefit of a periodic function, is that because it repeats, you can do that. And once you have them all, you go ahead and draw your waves, your periods. There we go. There we go. What's our period? Period's pi. How many cycles are we going to see here? All right, let's look at this. Starting at 0, there's 1 pi, 2 pi, 2. 2 distinct cycles. Mr. Weber, I didn't have to do that because you can just look at this value right here. Exactly right, generic student, exactly right. All right, here we go, number 8. 8's a sine function, so we're thinking about 0, 1, 0, -1, 0. There's nothing, there's no amplitude change, so we're not going to deal with that. But there is a vertical shift. All right, so let's subtract 2 to everything. Everything goes down by 2 units. And now we'll deal with the period. Okay, the b value is 2. So our period's going to be 2 pi divided by 2, which is just pi. So we take the first value, -2, the last value, -2. That's over the course of pi. So there we go, there we go. All right, look at the middle value, also -2, middle value. And then you have -1 and -3, boom, boom, boom. And there's your template. All right, so we're going to use this template to find the next cycle, the next wave. Ba-bam. Working backwards. Ba-bam, ba-bam. And we're going to graph it out. Okay, if this does not make sense, please, please, please don't hesitate to reach out. Let's look at the period. We already did that. The period's right here. It's pi. Number of cycles between 0 and 2 pi. Look right up here. It's 2. So guess what this is going to be? 2. Boom. Done and done. All right, but again, I want to remind you the reason that is because if we come back and look at this, there's 1 cycle. There's 2 cycles. So you can see 2 full cycles between 0 and 2 pi, and that's why this number is what it is. Okay, there it is, dealing with period shifts. Remember, what you have to find is the b value, the number that's in front of the x. All right, that b value will tell you the number of cycles between 0 and 2 pi. And if you take 2 pi and divide it by that b value, that tells you the length of 1 period, of 1 cycle. Okay, this is a little bit tricky. You're going to have to practice. If you have questions, please don't hesitate to reach out. Look at your teacher's office hours. They are here to help you out. Send them a message, pop into a Zoom. If you have a mind, do that. But if you have questions, ask them and get them answered, because there's no better way of figuring this out. Sometimes you just need to ask, and you need someone to sit down and explain it to you in a way that makes sense. So reach out. Good luck. I'm with you always. Hang in there. You can do it. All right, let's go. Go team, go.